Hello, in this video we're going to go over the head and tail functions in R for subsetting time series data. Thank you for watching. So the head and the tail functions are usually used to summarize a vector of data. So I'm just going to create, if you will, just a temporary kind of throwaway data. In this case I'm going to create a sequence just so that we can real easily see the differences of what kind of observations that we're missing. So I'm just going to create a sequence from 1 to 20. So this is going to give us just some whole integers counting up sequentially from 1 to 20. Okay, so let's start with the head function. If we type in the head function and then type in our temp object, what we're going to end up getting is just the head or the top part of that vector of elements. So in this case, it's usually I think it defaults to 6, and so it's going to give us the first 6 observations of this 1 through 20. And the tail function itself actually gives us has the same kind of functionality, but then of course it gives us the tail or the end of that data. So it's going to start with observation 15 and go to observation 20. Now I usually use the head and the tail functions in order to kind of set up my variables, especially if I'm dealing with lags. Sometimes I'll use certain type of time series algorithms where I can't necessarily use specifically time series class objects because I'm using it more in a vectorized format or in pure matrix algebra. But also this is helpful if you have what is essentially a time series data, but you're actually simulating something. Let's say you're simulating something like a Taylor rule where you have both data at time t, but then you also have data at time t minus 1. So you can actually use these head and tail functions to create these variables, if you will, and have them set up just right. So whenever you're dealing with something of a time series class where you have a variable at time t, but then it's a function of itself at time t minus 1, you're going to lose one of those observations. And so the use of both the head and the tail functions together allow you to have all your variables in your function to be of the same length. So in this case, we can do this by saying, I'll start with the head function first. We can put in our temp object, and then I'm going to actually give the additional argument minus 1. Now what this does is it gives us then the head of the data. Of course, then it leaves off then the last observation. In this case, it's removing minus 1. It's removing the last observation. So it gives us observations 1 to 19. The tail function operates in exactly the same way. So in this case, if we use the tail function, put in our temp argument, and then give us the additional minus 1 argument, it's going to remove the last one of that. But of course, since it's giving us the end, it's actually going to leave off the beginning of that. So the tail function gives us our variable starting at the second observation, going all the way to the end, while the head function gives us the first observation and going all the way to end minus 1. So in this case, if you were trying to model any time series object, then you can create the actual variable at time t, if it's to say a first order lag, using the tail function, because it will eliminate then the first observation and start at the second observation going all the way to the end. And you can then model that as a function of this other variable starting at t minus 1, which in this case would be the first observation, but then going to end minus 1. So you can kind of loosely keep in mind variables at time t, you can use the tail function. Variables at time t minus 1, you can use the head function, given that it's just one step removed, hence the minus 1. But this is a really powerful set of tools. I use these a lot, especially with my students when we're simulating things like Taylor rules where there's some past lag or past value in it. These things can come in really helpful. I hope you've enjoyed this video, and thank you very much for watching.